O'Reilly!
It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts.
O'Reilly Auto Parts.
Hello once again, and thank you for joining us on Space Nuts, where we talk astronomy, space science, sometimes technology, sometimes we talk about recipes. You name it, it's fair game on this show. And coming up on this episode, 291, we'll be talking about something you may well have heard mentioned in the news, and that is that Earth has picked up a Trojan asteroid. Yep, and it's going to be sticking with us for a little while from what I've read. And I got a message the other day from someone wondering if the James Webb Space Telescope could try and find Oumuamua, which I affectionately refer to as the Space Doogie because it's, cigar-shaped. Well, maybe not. I'm thinking it's too small for James Webb and probably too fast, but there is a possibility that they will go after it. So that's in the news as well. And an interesting story about a volcanic lake that has life in it. How so? And what does that mean for the potential for life beyond Earth? And we're going to tackle a question from Michael in Kent, who wants to know, once we land on Mars, what's the first thing we're going to do? Well, more specifically, what are you going to do, Fred? I know what I'll do. I'll tell you when we get to that part of the story.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
My name is Andrew Dunkley, your host, and joining me as always is astronomer at large, Professor Fred Watson. Hello, Fred.
Hi, Andrew. How's it going?
Oh, it's going really well. Yeah.
Yeah.
No complaints whatsoever.
That's good. I'm glad to hear it. Usually we have plenty, but not today.
Well, we could complain, but then that would use up all our airtime and we wouldn't be able to talk about astronomy.
No, we could complain about that as well. Look, we could throw in anything.
Yes. Do I dare use the term whinging pom? Fred, do I?
It's water off a duck's back.
Of course it is. Of course it is. Okay, let's go to our first story. And this one is really interesting because Earth has picked up a companion known as a Trojan asteroid, and it's sharing our orbit, and it will be sticking around for a little while. What's the story here? This is fairly newish type of discovery, isn't it?
Yeah, it is. It actually is the second known Trojan of the Earth. Let me get the details out of the way by telling you what it's called. It's called 2020 XL5.
Oh, I don't mind that one.
It's not bad, is it? It's quite, sort of rolls off the tongue. It's the second one. The first one was 2010 TK7, which is...
that's not bad either. Actually, we're getting a new car in a few months, and it's a 2020 XL5. So there you go.
Well, it's perfect. That's very good. Mine's a 2018 ASX, which also sort of, rolls off the tongue a bit as well. Anyway, never mind all that. What is it? What's a Trojan? It is a kind of asteroid, and they were really first discovered in the context of the planet Jupiter, because Jupiter has something like 11,000 of these things in tow. We've got two on Earth. What are they? They are asteroids that congregate in the two Lagrange points that are in the same orbit as the planet. Let's just talk about Jupiter for the moment. The same orbit as Jupiter, but they're centered 60 degrees ahead of Jupiter and 60 degrees behind Jupiter in its orbit. And these are the two Lagrange points. We've talked about Lagrange points many times. There are 5 of them where the mutual gravity of two objects, in this case the Sun and Jupiter, balance out and give you a gravitational null point. So they're called L1 to L5, and L4 and L5 are the ones that are actually in the orbit of the planet, so in this case, Jupiter. The other three, L1 to L3, they are basically along the line joining the sun and the planet. Make that clear? Yeah, I think so. With the most obvious one being the one between the sun and Jupiter. That's the L1 point, where just the gravity balances out between the two.
And L2 has been in the news because that's where James Webb is.
That's right. That's on the other side of the planet. So that's the Earth L2 point. So, Jupiter has these L4 and L5 points, the ones in its own orbit, and they have gathered up over the millennia these clouds of debris, so the Jupiter Trojans. And in fact, I can't remember which way around it is. There are two groups, the L4 group and the L5 group. One group is called the Greeks and the other group is called the Trojans. I can't remember which way around it, but that's where the name comes from. It's the idea of the Trojan Wars. You probably haven't seen it, Andrew, but I've got a picture of the Jupiter Trojans in Space Warp. It's a picture of what they look like, and they all seem to look a bit like horses with little wheels on the bottom of them. But I was quite happy with that cartoon when it came out. Anyway, so we've got these two clouds of asteroids, which are of great interest. And you and I have spoken about this before because there is a mission, excuse me, on its way to visit the Jupiter Trojans, which is called Lucy. And we discussed that a few weeks ago. Let's come back, though, to the case of the Earth, because, of course, the Earth is a planet. So you've got this gravitational interaction between the sun and the Earth. And that means that the Earth, too, has its Lagrange points. And you're absolutely right. L2, the one beyond the Earth, out on the direction away from the sun, that is where the James Webb Space Telescope is now located, along with a number of other objects, like the WMAP, that was the Wilkinson Microwave Anisotropy Probe. The Gaia spacecraft is there too. There's a whole gang of spacecraft. Now, they're not all trying to be sitting at exactly this one point, which would be a bit uncomfortable for all these spacecraft. But what they are doing is they're orbiting around that null point. So there's room for plenty of spacecraft there. James Webb is not likely to run into any of these other ones. So that's the L2 point. But the Earth, of course, has L4 and L5 points as well. L4 being ahead of the Earth in its orbit, L5 being behind. And back in 2010, this Trojan asteroid was discovered, 2010 TK7, an object about 300 meters in diameter. And it's been relatively well studied. There's not much known about it. It's very, very faint because it's so small. But now, and the reason why we're talking about this, because it's in the news, an international team led actually by a Spanish group, actually, University of Alicante and the Institute of Cosmos Sciences of the University of Barcelona. They have basically confirmed that this asteroid 2020 XL5 is a Trojan asteroid. And it's more interesting than the other one, partly because it's bigger. It's about 1 kilometer, if I remember rightly, thereabouts. I think 1,100 meters or something of that sort. But it is also, it's a carbonaceous asteroid. It's a C-type asteroid, which in fact is the commonest kind, but it means it's rich in carbon compounds. So it's a sort of pristine remnant from the solar system. And I guess that sort of begs the question, well, should we go and visit it and have a look at it?
I was going to ask you that.
I thought you might. I'm sorry.
Well, it's an opportunity.
It is, yes, that's right. The understanding I have at the moment, Andrew, is that there are no immediate plans because we've got this mission already on its way to the Jupiter Trojans, and that's going to, if I remember rightly, it's going to fly by 8 asteroids, one of which is in the main belt, and the other 7 Trojan asteroids. So it's going to have a really good look at these, and that will tell us a lot. But what will happen is that telescopes here on Earth will certainly make a point of studying the Earth Trojan, the new Earth Trojan. And in particular, the first thing that you study with one of these is the stability of its orbit, the dynamics of how it's behaving in this gravitational well. And if I remember rightly, I don't have this in front of me at the moment, but it's thought that within 4,000 years, I think that is correct.
Yep, that's the number I can see.
Okay. We're going to lose it because the gravitational, it will not be a stable orbit. It's not stable enough to hang on to this Trojan.
How did they come up with the number of 4,000 years? How do they know that that's the time frame?
Basically, just by fast forwarding, because you can, orbital dynamics are incredibly robust when you take into account the gravitational pull of the objects in question. So it's not just the gravitational pull of the Earth and the Sun that are involved here. The Moon is also tugging on this Trojan, as are the other planets. And if you add to that a little bit of an impulse coming from the solar wind, there's always that as well, this breeze of subatomic particles that's constantly blowing through the inner solar system. Put all of those together in a monstrous computer program and then run it forward, it tells you how stable the orbit is. There'll be, parameters that give you the stability of the orbit. When that drops below a certain number, then you're going to lose it. It's actually, this is a total aside, Andrew, but about 150 years ago, it's not quite that long, my master's degree, which was a research degree, I wrote computer programs for determining the orbits of asteroids. That's what I did, because back then computer programs were a novel thing. And so my thesis was called Practical Techniques for the Determination of Minor Planet Orbits, because asteroid was not considered a proper word in those days. And so I know a little bit about the kind of computations that are involved with this. And I mean, the stuff I was doing then was, totally prehistoric compared with the software that's being operated today.
Yeah. It reminds me, Fred, of when I studied in college. I did a computer class as one of the subjects, and it was 1 hour per week for the 1 year of the 4-year course. So they didn't put a lot of focus on it. Was actually learning to write code and things like that. But there wasn't much focus on it back then.
No, that's right.
I mean, the most powerful computer around at that time in my place was a Casio calculator. Yeah. Now, I do notice, Fred, that we've now got 2 Trojans, and you said Jupiter's got about 11,000 or something. Neptune's got 32.
Yeah, that's right.
They say.
Yes.
And Mars has got 9, and not surprisingly, Uranus has got 1.
Exactly. Yeah, the Mars having 9 is interesting, but I guess you can equate that to the fact that Mars is right next door to the main asteroid belt. So some of those might well be, captured objects that have dumped themselves into this gravitational well in the orbit of Mars.
So that would suggest then that there are more Lagrange points further out.
Yeah.
That, we go L1 to L5 because they're in our vicinity, but further out there are others.
Yes, that each planet has its own. So every planet has its own L1 to L5, and as do asteroids and dwarf planets. So Pluto would have an L1 to L5, actually, which wouldn't be that different from the Neptune ones, because Pluto's orbit is not not that much bigger than Neptune. It's elongated, but at its closest, Pluto comes within the orbit of Neptune. So it's that neck of the woods. Yeah, really interesting stuff. And something else that this issue raises, which is quite interesting, is the possibility of looking at the Lagrange points of exoplanets, see what we might find there when we've got telescopes that are powerful enough to do that.
That will be interesting. Yeah, I suppose it's like we speculated for a long time whether or not other solar systems existed beyond ours, and we've proved that's true, and we're starting to learn more and more about those exoplanets, and some of them are very much like the ones in our solar system, and some of them are very, very weird indeed. But it stands to reason that what's happening here would be happening in many, many other places in the universe, probably millions of times over.
That's right. Yes, that's absolutely right. Because, because the laws of physics are the same everywhere. That's the bottom line. So what happens here is going to tend to happen elsewhere as well.
Okay. All right. So, 2020 XL5, we've got plenty of time to decide whether or not we want to go and visit it. It's going to be hanging around for about 4,000 years, which is probably just enough time for bureaucrats to make a decision.
Oh, they start thinking about it now. They'll probably manage it. That's right.
Indeed. You're listening to Space Nuts with Andrew Dunkley and Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, if you are a social media follower, you can follow us on social media, which is very convenient. It's a good way to stay in touch with what's happening with Space Nuts. You can do that on Facebook or Instagram. You can also join the Space Nuts podcast group on Facebook, which is a gathering of people who listen to the show that can chat to each other, share their photographs, share their stories, share their jokes, all that kind of thing. So, yes, social media is a good platform for us, not only to stay in touch with you, but also for you to stay in touch with us and each other. So check it out, Space Nuts, the official Facebook page, Space Nuts podcast group on Facebook, and our Instagram page. We're on Twitter as well, if you're a Twitter user. I'm on all of them. I don't know how to use any of them, but I'm there. Now, Fred, we're going to discuss one of my favourite subjects because a few years ago now, there was a flyby of Earth by a large interstellar object. It was Oumuamua, which passed through our solar system. We didn't know it till it had got past, so yikes. And because of its incredible shape, and I've already made references to something like this in the program about Uranus, but I call it the Space Doogie because that's what it looks like. And we've had people sort of jokingly saying, oh, well, why don't we go after it? Can we get pictures of it? What does it look like? And I think I, tongue-in-cheek, said, well, there's a Tesla out there. Why can't we go after it in Elon's car? Well, now it looks like they're thinking about it.
Yes, without the Tesla, though.
Not necessarily in the Tesla, but
Yeah, they are. That's right. Well, people are fixated by this object.
they certainly are.
As well, you being one of them. Just to catch up a little bit on it. So it was back in October 2017 that Oumuamua passed through the solar system. Its name comes from a Hawaiian word meaning first visitor, first messenger from afar, I think, something of that sort.
Mm.
And what the only observations that we have of it, Andrew, to do with its brightness and its color, because that's all you can see with big telescopes. And telescopes were focused on it as soon as we knew about it, because it as you said, it had already passed its closest when it was discovered. The key thing, I guess, was that it has this extraordinary light curve. And by that, I mean the way its brightness varies over time. I can't remember. I think is it 40 minutes or something? It's a long time since I've looked at this. But its brightness varied enormously over a short period of time and quite regularly. And when you model what that's telling you, is that the first thing that came out of it was the possibility that it was essentially shaped like a cigar or a French breadstick or anything else you want to compare it with, long and thin. I think quite long, actually. If I remember rightly, it was more than 100 meters long and so that modeling was what was taken as read for a long time, that it was cigar shaped effectively. That, coupled with the color, which you can also measure pretty easily from ground-based telescopes, because all you're seeing is a point of light, so you can measure how it varies over time in brightness and what its color looks like. And its color is quite reddish. So those two facts all fed into our current understanding. But then I think it was last year, Andrew, you and I did talk about this. Some new modeling was done that suggests that no, it's not actually cigar-shaped, because something else that fits it is basically the shape of a saucer or a dinner plate, that it's a flattened disc that's also tumbling. And more work was done on the coloration, and it turns out that it was an exact match with the reddish areas of Pluto, which are thought to be made of nitrogen ice. There's a kind of covering of nitrogen ice on parts of Pluto. And so the theory then was that what we were seeing was this shard of solid nitrogen, which basically had probably been knocked off a Pluto-like object in a distant solar system by a collision and flung out of that solar system and is sort of heading through space. And I've just remembered a bit more why that was seen as a good model. And the idea is that as it gets near the sun, the nitrogen sublimes. It turns from a solid into a vapor. And it behaves a bit like, and there's one in my bathroom right now, a bit like those nearly worn down pieces of soap that you wind up with before you say this is ridiculous and throw it in the bin. A thin shard of material, because that's what this sublimation process would do. It's just wearing it down. And I think there was some, at least thinking, maybe not evidence so much, but the idea that as Oumuamua passed near the sun, it had actually lost some of its nitrogen, although there was no sign of that. That was the thing. And let me just I mean, this is a big recap on Oumuamua, but let's throw into the mix the aspect of it, which is that it was demonstrated to have non-gravitational forces acting on it. In other words, it wasn't just the gravity of the planets and the sun that were dictating the way it moved. There was evidence there was some other force which was thought to be this outgassing process as material, as vapor leaves the surface of Oumuamua, it gives a thrust in the opposite direction. That led certain well-known astrophysicists to postulate whether, in fact, this was an out-of-control alien spacecraft which was leaking fuel or something of that sort. So that, and because you've got no way of disproving that, in fact, no way at all. So you've still got all these possibilities. It's a cigar, or it's a worn-down piece of soap, or it's an alien spacecraft. And that's why people are saying, oh, my God, we've got to chase after this thing. And so scientists have looked at exactly that. How can you do it? And the answer is not quickly.
Yes, that's.
There is something called Project Lyra, which I think was initiated as a result of Oumuamua. And this is one way of looking, one of the projects that's actually looked at the possibility of chasing after an interstellar object and rendezvousing with it. So that group and other groups have looked at what you could do and how you do it. And the problem is, Oumuamua is moving at 23 or probably more now, or probably a bit less actually, because it's moving further away. But it's that sort of order of kilometers per second. Every second that goes by, it's 20 odd kilometers further away. And so you've got a big job to catch.
That's a big chase.
To catch up.
That's a huge chase.
It's a huge chase, that's right. And to cut to the chase, sorry for the pun, the Lyra group has published, I think I'm getting this right, there's several groups here involved with this, actually with this work, how you would do it. But a number of articles have been published, some of which use the idea of a solar sail. And, and we've talked about that before. And of course, Breakthrough Starshot, which is one of the breakthrough projects, has looked at the possibility of solar sailing to Proxima Centauri. And so there's a bit of interest in that kind of technology. So there is interest in a solar sail, but there's also interest, Andrew, in some very clever maneuvers to boost your spacecraft out of the solar system to get on the tail of. And these are a bit different from the standard gravity assist things, which you and I have talked about many times, where you fly your spacecraft close to a planet and it gives, some of the momentum of the planet is transferred to your spacecraft and gives it a boost. There's something called a solar Aubert or Aubert maneuver, which is a way of, you basically give your spacecraft a kick when you're moving as fast as you're going to in the orbit. In other words, in the case of the sun, perihelion. Perihelion where your spacecraft is at its closest to the sun on an elliptical orbit. And if you give the spacecraft a kick at that point, then that gives you a bit of extra oomph. That's putting it very, very crudely. I'm sorry, any astrodynamicists who are listening to this, you should just switch off now. But that's kind of the way it works. But there is a suggestion of actually doing a similar thing, but not using the sun, but Jupiter, using a Jupiter-Oberth maneuver. And so, the bottom line is, when you add all this stuff together, you could possibly catch up with, in a journey time of 26 years, if you launch to do that by 2028, because you've got to get Jupiter in the right place to do it. So,
which by my calculations means that if they follow through with this plan and do it in the timing we're talking about, they will intercept Oumuamua in 2054.
That's exactly what I calculated as well. That's right. 2054, yeah. So,
and we'll be there to report it.
I hope I will be. 2054, Andrew, I'll be 109. And
well, it's possible.
It's not impossible, but it's unlikely. And if I talk garbage now, imagine what I'm going to talk.
Yeah, I'll be 92.
Dear. Well, it's something to look forward to. I mean, what we can look forward to, maybe, is the launch of this thing, because that in itself will be very exciting. And you might say, well, okay, we're not going to make it probably to see the rendezvous. So we might never know what Oumuamua really is. But it's, at least we'd have the knowledge that somebody had done something about it.
Yes, exactly. Well, it's a rare opportunity, isn't it? We've only had two of these things.
Yes, that's right. But I think your point there is points actually towards what we really should be doing about this, and maybe a better way of dealing with it. And this has also been proposed in the wake of Oumuamua, because telescopes are always improving, because we're always able to see fainter objects. There is a lot of interest in solar system objects and interstellar objects.
You're going to say we're going to catch one coming rather than...
We need to find another one. We need to find it early enough that it's going to be intercepted as it passes through the inner solar system. A few pundits have suggested that what we need is a ring of spacecraft, probably spread around the orbit of Venus or maybe the Earth, that sort of area, maybe at Lagrange points, actually, L4 and L5.
Yep.
You put a spacecraft there, you park it there, all ready to go, all fueled up with it, all its sensors and all the rest of it. And as soon as one of these things comes by, you set off your spacecraft to intercept it, because it's all ready to go. All you've got to do is press the button. And
I like that.
I think that's a better idea, because you and I might get to see what the answer is.
Yeah, well, that's true too. Yeah. I mean, I know you've got to be patient when it comes to astronomy and observations, but 26 years plus 28. Not my idea of fun.
Not really, no.
But worth pursuing, perhaps.
Yeah.
Yeah, maybe we could just park the planet in front of it and touch it that way and make a movie about it.
Well, then you'd have another problem. You'd have,
It would indeed, yeah. But no, fascinating that they're considering the possibility. This is Space Nuts. Thanks for your company. Andrew Dunkley here with Fred Watson.
0G, and I feel fine.
Space Nuts.
Thanks again to our patrons who put a little bit of money in our bucket every month to support the show. If you would like to be a patron, you can jump on our website to find out more, spacenutspodcast.com, and just click on the supporter tab or button. And thanks to those who've been giving us reviews on their various podcast platforms. We appreciate that, and please keep them coming. Another thing you can do on our website is buy us a cup of coffee. I love coffee. I am a coffee addict. So, yes, that's another way of supporting us without having to, break the bank. So you can do that all via our website, spacenutspodcast.com or spacenuts.io. Now, Fred, we have in the past talked about some of the harsh conditions that exist in the universe and whether or not life could survive. And we've seen, experiments with tardigrades on the International Space Station surviving the vacuum of space. And now another piece of that puzzle may well have been revealed, in that they have been looking at a particular volcanic lake that has life. Is that what
Yeah.
they're saying?
Exactly that. Interesting story. So the story takes us to Costa Rica, where I think it's Poash pronounced volcano has a hydrothermal crater lake whose name is Laguna Caliente. How's your Spanish?
About that good?
Laguna Caliente means hot lake. So
Of course.
tells you exactly what you want to know. It's a hot lake. It kind of steams away because it's in the crater, so it's heated geothermally. However, this lake is interesting because it is highly acidic and it's got high concentrations of toxic materials, including metals. The phys.org article on this, I love their language. I'm quoting here. It says the temperatures range from comfortable to boiling. so it's a pretty grim environment. Plus, you've got these occasional steam eruptions where you've got, they're called phreatic eruptions, where the heated water just explodes basically, and you've got a steam eruption.
There was a famous case many, many years ago in, is it Ethiopia or somewhere like that, where one of these lakes actually erupted and killed hundreds of people and thousands of cattle because of the carbon dioxide gas, I think it was.
Yeah, that's right. Yes, I remember that. Yes, indeed. Yeah, I think it may have been even higher numbers of people. I can't remember the details.
Yeah, it was a large number of people. They just suffocated basically
because of the CO2. Yeah, horrible. Anyway, this lake, Laguna Caliente, has been studied by scientists at the University of Colorado Boulder in the USA. A lot of planetary work goes on there, and well, what do they find? It's got microbes in it, but it's only one species of extremophile. It's a group of microbes whose name is not surprisingly acidophilium, acid lover, I guess, is what it translates as, acidophilium. And it's apparently found, it's fairly commonly known, in acidic environments elsewhere. But this particular environment is so extreme that people have been surprised to find thriving colonies of acidophilium. And what's been studied, just to sort of cut a long story short, is the way this, the diversity of exact species among this genus of acidophilium, this particular species of microbe, the way they have changed over time, because there have been eruptions. I think the University of Colorado Boulder group have visited a number of times, starting in 2013, I think, again in 2017, and looked at the way these organisms have changed, in particular in the diversity of exact, species between the different classes of acidophilium. And really, this and other species, I should say, because it's acidophilium is dominant, but I think there are other extremophiles. I'm sort of garbling a bit here, but basically, I'm going to quote actually once again from the phys.org report on this, because it's really interesting and and puts it more concisely than I can. Through DNA sequencing of the organisms in the lake samples, the team confirmed that the bacteria had a wide variety of biochemical capabilities to potentially help them tolerate extreme and dynamic conditions. These included pathways to create energy using sulfur, iron, arsenic, carbon fixation like plants, both simple and complex sugars, and bioplastic granules, which microorganisms can create and use as energy and carbon reserves during stress or stress or starvation. It's one of the scientists involved with this says, and this is a quote: "We expected a lot of the genes that we found, but we didn't expect this many given the lake's low biodiversity. This was quite a surprise, but it's absolutely elegant. It makes sense that this is how life would adapt to living in an active volcano lake." And of course, the reason why you and I are talking about on Space Nuts, Andrew, is because there are similar environments we know did exist on the planet Mars, that hydrothermal areas of hot springs on Mars. That's the big connection. So another quote from one of the authors: our research provides a framework for how Earth life could have existed in hydrothermal environments on Mars. But whether life ever existed on Mars and whether or not it resembles the microorganisms we have here is still a big question. We hope that our research steers the conversation to prioritize searching for signs of life in these environments. For example, there are some good targets on the crater rim of Jezero Crater, which is where the Perseverance rover is right now.
Exactly. Yeah. So they know what they're looking for, basically, and this adds more evidence to it. And, of course, there are other targets in our solar system, such as the ice moons that send up their plumes from deep within. So there's all sorts of possibilities. And as you and I have said before, we're very hopeful that they will discover signs of past life on Mars and possibly life existing now in our solar system, and hopefully within our lifetime that this will be proven. So we wait with bated breath. But if you want to read that whole article, it's on the phys.org website. It's a fabulous website. I visit it quite often, and full of great information and articles that it very, very highly esteemed, in my opinion.
Mine too.
And yes, we're going to continue our journey to Mars right now, because we have a question from Michael, who has a few thoughts about his national.
Hi guys, it's Michael from Kent, UK. First of all, I have to thank you for such an amazing show you guys are putting on. It's nice to see a fellow Brit showing the world our intelligence. And the show just makes my journey to work there and back so much better. Bit of a weird question, really. Bit of a one to get your brain going. Obviously, humans want to be colonising Mars in the future. Obviously, not in our lifetime. I just want to know, if you was to go there and you had the opportunity to, and you went there, as a scientist, what would be the first thing that you would want to be going on with? What was the first thing you want to do, and why would you like to do that? As I said, amazing show. Can't wait to see some more in the future. End it on a joke. Why can you never trust an atom? Because they make up everything.
Thank you, Michael. Love the joke. And I'm sorry to break it to you, Michael, but I'm actually Australian. So I don't know why you got so confused.
One of us isn't. Well, I am too, actually.
This I was about to say.
But, however, it was great to hear from Michael. That's a fantastic. Thanks ever so much for your kind words, Michael. It's great to know that people in the old country are listening in and enjoying it. That's fabulous. That cheers me up no end. I
love the joke too.
I can never remember jokes, Andrew. That would be a great one to remember.
We've had a few sent in lately, so it's been good.
It's wonderful. But I like the question as well. And, you touch a nerve with me as soon as anybody mentions colonising Mars. I'm always thinking, really? Is that really what we want to do? And as you probably know, well, you know this, Andrew, maybe Michael does too, I'm a big fan of artificial megastructures. We build rotating space stations and create our own environments. And that lets us wander through the solar system and check out wherever we want to, rather than trampling hundreds of millions of people over the sands of Mars.
Yeah.
Do you want me to go first with what I do, or are you going to tell me what you do first? As soon as you
First thing I'd do on Mars, I'd hit a golf ball. They did it on the moon. I want to be the first person to do it on Mars.
Yeah.
And you know what? Unlike the NASA astronaut, was it Shepard?
It may have been. I can't remember. I don't know. Yeah, who you mean.
Mine won't go in a crater. So there.
Don't you have a problem on Mars, though? Because the whole planet's one big bunker with all that sand.
Yeah,
you just got a sand trap everywhere.
I've played golf in Dubbo through several droughts, so I'm very good at hitting off dirt. Very, yeah. No, seriously, I don't know what I'd do. I think the first thing I would do is explore. I'd want to get out there and have a look around. I'd want to see it. I know that's probably very unexciting, but that for me would be priority one. Get the lie of the land, learn from observation what it is, and, just absorb it. That would be my first priority.
I think actually it'd be something similar for me. I mean, I'd love to feel what 1/3 of Earth's gravity feels like. And you're doing that with the golf ball. I might try and jump up and down a bit and see what.
Yeah, well, knowing that I could hit it nearly a kilometre would be a thrill.
Yeah.
But I suppose the other thing is I'd like to experience verbal communication, because its atmosphere is so different to ours, and I've heard an example of it. To talk to each other on Mars is very difficult because
So
that's what I'm told you would sound like.
sound like anyways, doesn't it?
Yeah.
Yeah, the trouble is, once you take your space helmet off to try and do that, you die because the pressure's only 1%, 0.6% of Earth's. There's lots of things you could do. I'd take my bucket and spade and have a play in the sands of Mars, perhaps. But I guess one thing that I would be fascinated by, and this may not be within the scope of Michael's question, but supposing you and I went to Mars, Andrew, and we could do anything, maybe we could hitch a ride on some rover to go and find the remains of Ingenuity, which at the moment is still flying around, doing a great job on Mars, the Perseverance helicopter. I would love to have a close-up look at Ingenuity and see how it survived its sojourn on Mars.
Yeah, I've just thought of something else I'd love to do. I'd love to climb to the top of Olympus.
Oh, yeah.
Yeah, because I'd technically be leaving the atmosphere of the planet.
Yes, that's right. Yes, yeah.
So I'd be able to say that I achieved enough velocity to leave the atmosphere of Mars on foot.
Yeah, trouble is, a vertical height of, 23 kilometres? It's a bit of a climb.
It's a heck of a... Well, if you go from the very edge, it's hundreds of kilometres.
Well, that's right. The distance, the horizontal distance that you're walking is hundreds of kilometres, but the vertical distance alone is 27. I guess, on top of that, you've only got 1/3 of Earth's gravity, so your muscles will do a bit better job. But that would be, the view from the crater rim of Olympus Mons. Now, that is...
awesome.
That's a really good answer, Andrew. I like that very much.
Well, my obsession with volcanoes notwithstanding, it remains one of the pieces of the solar system that I'm most captivated by. And Mars, as you know, is my favourite planet. So
got it all. Wow.
Yeah. Anyway, that's what we might do. Michael, did you want to add any more, Fred?
I think we've covered it. By the time we've picked up the bits of Ingenuity wherever they are and climbed to the top of Olympus Mons, I think we've got a lot to write home about.
Absolutely. Yeah. Thanks, Michael. Thanks for the joke as well. Lovely to hear from you. And one more thing, of course, if you do want to get in touch with us, you can do that via our website, and you can send us messages there in either text or voice styles. Just click on the respective links to get in touch with us. The AMA tab at the top, or the record your question tab on the right-hand side at spacenutspodcast.com or spacenuts.io. That brings us to the end of another episode. Fred, thank you so much.
Andrew, always good to chat about these things, even though they might not make much sense, but that's all right.
Who said we had to make sense?
Yeah, that's right.
That wasn't part of the initial idea. So anyway. All right. Thanks, Fred. We'll catch you next week. Fred Watson, astronomer at large. And from me, Andrew Dunkley, thanks for listening, and go the Bengal.
Space Nuts.
You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.